Before starting with number 55 here, I just want to mention I have some videos posted that explain things in a more step-by-step and detailed manner. So any one of these three videos might be a little bit easier for you to understand if I'm proceeding too quickly. And any of the videos from 11.4 are going to show factor by grouping and the box method. And basically any of the videos from chapter 11 are going to have some topic on factoring. So difference of squares, which is what we're going to pick up with here on number 55. The difference of squares is covered. Let me see where that's covered. That's in section 11.5. Okay, so any of the videos you find in YouTube that address, at least the ones that I've made, that address from 11.5 are going to have difference of squares examples. All right, so proceeding down this list that I referred to, you'll want this handy if you don't already have it. I've shown this on a lot of other videos. Number one is GCF. There's no GCF. Two terms. Yes, we have two terms. Is it a difference of squares? It's a difference, and those are perfect squares. So the answer to that is yes. It means you can factor it. You simply take the, actually I think I'll put it right on here. You take the square root of 49, x squared, and that's 7x. So you'll have a 7x there, 7x there. The square root of 16 is 4. And then you just have to remember that one set of parentheses will have a plus, one set of parentheses will have a minus. So this is the factored form of this binomial. Okay, and in order to see that if this gives you any trouble, you really need to go ahead and multiply each term here by each term here, and you'll see your middle terms cancel, and you'll end up with 49x squared minus 16. Okay, we'll also take a look at number 56, and it might look strange, but number one, is there a GCF? No. Number two, I don't feel like that's going to be distracting for people. So I'll cover it up. There, that's a little better. Okay, so number 49. Number one on the list, GCF. Is there a GCF? No. Number two on the list, do you have two terms? Yes. Then that refers you to ask, do you have a difference of squares? And the answer to that is yes. You have a difference, that's a perfect square, and that's a perfect square. So to write the factored form, the square root of 49 is 7. The square root of w squared is w. And then you just have to remember that one gets a plus and one gets a minus. If you multiply these together, you'll get that. Okay, 56. We'll also take a look at 57. I'm just going to push that up there. And this one might look strange, but it is a difference of squares. Okay, that's a perfect square, and that's a perfect square. All right, so the square root of t squared m squared is tm. So you'll have a tm in the first position. The square root of 1 is 1. And then you just have to remember to put a positive in one and a negative in the other. And this is the factored form of t squared m squared minus 1. All right, we're also going to take a look at number 58 here. And let's get that on our screen. Okay. And might look a little intimidating, but we've just been talking about difference of squares quite a bit. So, x squared is a perfect square. So I think I'll kind of proceed down the list. If you get in trouble, you want to refer to the list, the rules for factoring. Is there a GCF? No. Do you have two terms? Yes. Is it a difference of squares? You have a difference. X squared is a perfect square, and 25/36 is a perfect square. The square root of 25/36 is 5/6. Okay, so that means you can factor this. The factored form: square root of x squared is x. The square root of 25/36 is 5/6. 5/6. And you just have to remember one is a plus and one is a minus. Okay, this is the factored form of that binomial. And then number 59. 59 has one other little trick going on. So let me try to cover up a little bit of this so it's not so distracting. Alright, number 59. You proceed down the list. Number 1, is there a GCF? No. Number 2, do you have two terms? Yes. Is it a difference of squares? Yes. So you take the square root of the first term, that would be x squared, and that goes in the first position. The square root of 81 is 9. Okay, and then you just have to remember to have one is positive and one is negative. But you actually keep referring to this list each time. Usually you can't go any further, but you would still refer to this. You would say, is there a GCF? No. Do I have two terms? Well, yeah, I've got two terms here and I have two terms here. Is either one a difference of squares? That's not a difference, that's a sum. But this is a difference of perfect squares. So I can actually go another step here. Okay? So the square root of x squared is x. The square root of 9 is 3. And you have to remember one's positive, one's negative. Okay? So this x squared plus 9 is going to be sitting in front. X squared plus 9. And then this can be broken up into these two. Okay, so that's not there anymore. It turns out that this is the factored form of x to the fourth minus 81. Okay, usually you can't keep going, but once in a while that happens. Alright, so that's the 59. I think that'll take care of it.